Hello friends, I'm back with a new video. This time we'll be learning Fe and Fe3C diagram, that is iron carbide diagram. If we're gonna write, this is iron carbide diagram. Okay. Okay. So basically we need to understand certain temperatures, certain composition of carbon in a graphical manner. So what we will do, we will take uh, our y-axis, okay, and we will take an x-axis, and with that we will do a secondary y-axis. Okay, so in the x-axis, in the x-axis, that is our this axis I'm talking about, we will be having, let me write here, in the y-axis we will have the temperatures, okay, in degrees, and in x-axis we will have percentage of carbon. Okay, okay. Let me mark, this is a point, this is 0%, this is 0.02, this is 0.8, supposedly this is 1%, this is 2, this is 3, this is 4, this is 5, and this is 6, and this up to this point it's 6.67% of carbon. Okay, next what we are doing, we will be marking the temperature in the y-axis. Supposedly in different books or textbooks you will find the range of these temperatures differently written by different authors, but it should be approximate near to a certain value. Like if someone is mentioning 1400, it should be like 1493. No, I mean to say, if it is 1400, it should be near in and around 1400, like 1394 or 1405. If suppose someone is mentioning it's 600, it should be 585 or 590 or 605. So let us mark this point as 15, 1539 degree, and let us suppose this thing is 14, let us suppose this is 1393. Okay, we'll mark this to letter. This one is 9, 10, and this one is 768. Okay, already degree Celsius. Okay, so let us, this thing is 1400 and this thing is 1493. What we will do, we will take a certain point. Let us suppose this is our certain point, which is 0.008. this point. Okay, so perpendicular to this point, if we go in this way, suppose parallel to this point, let us suppose mark a point. Okay, just suppose mark a point and join these two points by a two straight line from this point and from this point. Okay, okay, this point. Okay, wait a minute. Yeah, sorry. Yeah, these 2 points. Now, parallelly from this x, take another straight line. Sorry, it's getting curved, but it should be straight with this 0.8 percentage, and we will mark another point parallel to the same line. And what we will do is we will join this one, this point and this point. Okay, okay. Next, what we will do, we will take certain point in this line and we will join it. Okay, it should be between 0.8. This point should be between 0.8 and 0.08 and 0.8 percentage of carbon. Next, what we will do is we will take a certain point above 910 and certain point below 768. The point that we are considering in this graphical context above 910 should be in parallel to this 2 percentage. Okay, this point we have considered, and suppose there is another point at 0.8 percentage less than 768. So one point more than 910 and the other point less than 768. What we will do is that we will join these two. Just a minute, it's getting curved. Sorry, it should be perfectly a straight line actually. Okay, and the other point is this point. Okay, both are straight line, and what we will do, we will join these two. Estimate it's getting straight. Let's make it straight. Okay, so we completed up to this point. What we will do is that we will now draw two straight lines. Okay, draw two straight lines touching this point, and from this point we will draw another straight line. These two straight lines are the transformation point. Okay, transformation phase line, you can say. It is around 1147 degree, and it is, since it's less than this 768, it's around 727. Okay. Okay, now what we will do is that we'll take a certain point between these two, certain point. Okay, we'll take certain point, these two, and from this point we will draw a line on this 0.8, on this 0.8 and sorry, just a minute. we'll take a line from here to a point parallel to this line. So it will be like this. Okay, and the other line that will be joining will be somewhere between 768.0, and this point that you are seeing can be at a room temperature. It can go from this point to here also. Let us consider up to this point. Okay, so we have the main diagram actually, and let us make some the rest of the lines in the entire iron carbon diagram. Okay, let us suppose this is 4.3. In the x-axis you can see, this is 4.3. Let us draw a straight line from this point. Okay, this point that we have found with this parallel horizontal line and this straight line, vertical straight line, this point can be called as eutectic point. Okay, and this point can be called as eutectoid point. Am I clear? Okay, let us do one thing. Okay, just a minute. Okay, as we have drawn this line, we have made a simple mistake. Suppose let us draw this line from this point, that we have taken. This is just a minute. Let us draw it a good straight line. Okay, good straight line. Okay, let us try. Just a minute. I'm making a mistake again here. Okay. This can be quite good. Okay, what we will do, we can see a part that is coming out, this straight line. This is a certain point and there is another point. What we will do, we will do a curved line from this point, and from this point another curved line to this point. Okay, and from that point we will draw a straight line from this point, up to this y-axis, but this temperature will be in between this 1493 and 1400. So if we take a certain temperature in between, it will be right here. So it will be a straight line. Okay, so this is the actual diagram with the lines, graphically represent the lines. Now we're coming up with the names and the symbols. Okay, let us take the red line. It will be quite good. Okay, so this is our delta iron. Okay, this is our liquid iron. Okay, this is delta plus L. See, as the temperature is moving up, we will be having the solid iron into liquid iron. So this portion is delta plus L. This portion is delta plus gamma, because this entire portion is gamma. Gamma is an austenitic structure. We'll come into that point what delta is about, gamma is about. Okay, and this portion is our alpha. This is alpha, means the ferrite. It is also a BCC structure. Okay, so this transformation line can be called as eutectic line. This can be called as if this line, the eutectoid line, this second line is the eutectic line, and this isotherm. Why I'm saying isotherm? Because it's has a constant uh, temperature, so this is called the peritectic line. Okay, so next is that what we will do, this is alpha plus gamma. Okay, okay. uh, we should know one thing, up to 0.8%. Okay, this is hypoeutectoid. This entire region is eutectoid, so this portion is hypoeutectoid and this region is hypereutectoid. Okay, eutectoid. Okay, so our entire this portion, is alpha plus Fe3C. Okay, we should know alpha is BCC ferrite and gamma is abscess structure called as austenite. Okay, and our delta is again a BCC ferrite. Okay, one should know one thing, that this there is a term called pearlite, which is nothing but the addition of alpha plus this Fe3C. If we add this alpha ferrite plus Fe3C, we will get pearlite. Okay, so this Fe3C can be called as cementite. So I hope it is quite clear what is alpha, what is gamma, what is delta, and what is pearlite. Okay. Okay. Next, there is another term that we will see, is called ladeburite. Just a minute. Okay, this ladeburite, as we have seen in case of pearlite, is alpha plus Fe3C. In ladeburite, it will be gamma plus Fe3C. So in this case, we will be seeing what is alpha plus Fe3C, that is pearlite, and we will see what is ladeburite, alpha, non-alpha, gamma plus Fe3C. So we have known this thing, and let us complete the symbolic kind of thing. This is gamma plus L. Okay, as this, the entire line is alpha plus Fe3C, this entire line, okay, this entire line is gamma plus Fe3C. Okay, okay. Since the liquid, so this region is L plus Fe3C. Okay. Now one should know that this up to 2% and greater than 2%. Up to 2% it is steel, and from 2% to up to 6 this percent it is cast iron. Okay, just a minute, 1 second. Okay, so we can see certain portion. As you can see, this uh, point 0, this 0% of carbon up to 0.8, and this point you take to, and this point, this entire region, as you can see, this entire region, let me make it using another color that will be much more clearer for you. Okay, just a minute. Just a minute. uh, this thing, and there will be another region, this region from point 8 to point 2. There will be one region, hypo region, and there is a hyper region. Okay, so in case of hypo, sorry, in case of hypo, what will happen is it will be peer light plus Fe3C. In case of hyper, it will be, sorry, it will be uh, peer light plus ferrite. In the hyper, it will be peer light plus Fe3C, that is cementite. And beyond 2%, this portion I am talking about, sorry, this portion, we will have this one is peer light plus Fe3C plus transformed lead-burette. Okay. Next, we will come to this point. Like we have found this point, this point, this point, and this point. So up to this point, if we can see, if we make it into two parts, and this point, okay, these 2 points, what we can see is that this is having a lesser, this part is having a lesser, though the both part is lead-burette plus Fe3C, this is gamma plus this part, mainly this part, this is gamma plus Fe3C, this part. Okay, but as we go from this point towards this point, what will happen? There will be less gamma and there will be increased number of Fe3C as we reach in this towards the right. So in this case, the entire region, this entire region is lead-burette plus Fe3C, but near to gamma, the percentage of gamma iron will be much higher, and towards the right, the Fe3C percentage will be higher. So this is what is all about in general our iron carbide diagram. Okay, so what we have seen is that we have seen certain sorts of temperature in the y-axis and certain sorts of percentage of carbon in the x-axis. Okay, and there are mainly 3 lines, that is eutectoid line, eutectic line, and the peritectic line. And these lines are isotherms, means the temperature is constant. Okay, and we have seen what do you mean by the alpha iron and the gamma iron and the delta iron. Okay, and how peridot is constituted and how lead-burette is constituted. Okay, and what is Fe3C in both the cases. Okay, and up to what percent is steel and up to what percentage of carbon it is cast iron. In this way we can find out the different composition at different temperature, different phase line in the iron carbide diagram. So I hope it is quite simpler for you now, and I hope I could make some clear points about this concept. We'll meet in the next video with the reactions of these three lines: paratactic, eutactic and eutectoid line, with mentioning the temperatures and the percentage of carbon. Thank you.